Welcome to EDU World Space.
A white dwarf is supposedly held in equilibrium, basically, with something called an electron degenerate gas. In this state, the electrons, which are fermions, are as closely packed together as they possibly can be because of the Fermi principle that no two electrons want to be in the same state. So if you try to pressure them more to get together even closer, they basically rebel and will not do that. But what we're going to use is that if we imagine them closely spaced together as much as possible, there is still some uncertainty in their spacing. And we're going to call that of the order of a picometer. Very small amount. And we're going to use the uncertainty principle to figure out something about their speed. So the Heisenberg uncertainty principle says that basically the angular momentum components each have an uncertainty. The x and the momentum have uncertainties. That's what the delta means. Kind of like a error, if you will, but multiplied together, that is of the order of h bar. And it's approximate, but we will go with that. And what we're going to use this for is we are going to find the uncertainty in the speed of the electrons in this electron degenerate matter. Okay, so that's not too hard to do. The uncertainty in the momentum is simply equal to the mass of the electron times its uncertainty in speed. So working that out, delta V is h bar over mass times uncertainty in position. And just a reminder that h bar is the same as Planck's constant. And I'll write Planck's constant down in SI units, joules times seconds, divided by 2 pi. And then we have the mass in SI units. And we have the uncertainty in position. And working that out, if we have units of SI units, this should work out to give us meters per second. I should probably show that, but I feel confident it comes out that way. So we get uncertainty in velocity is of the order of 7.7 times 10 to the 7th meters per second. And what this demonstrates is if you compare this velocity to the speed of light, you find out that this is a fairly significant fraction of the speed of light. That is, V over delta V over C is of the order of 25% the speed of light. And so that means this is just the uncertainty in the speed. But because this uncertainty is so large, it means you could have a velocity or a speed that's relativistic inside of these stars. So relativity is going to be important. And probably both general and special theories are probably needed for the interiors and the nearby atmospheres of these white dwarfs.